Hello, today I'm joined by Ira Cohen, who is the co-founder and chief data scientist of Anodot, a business monitoring company. Hello, Ira.
Hi, nice to meet you and a pleasure to be here.
Yes, and perhaps we can start by just giving a bit of a background to Anodot and how you help telcos.
Right. So Anodot is a company we founded in 2014 with the goal of changing the way people monitor their business to be a lot more autonomous. And the way we achieve it is by collecting data from many, many different sources, transforming them into time series metrics, and then having algorithms, basically machine learning algorithms, automatically detect anomalies in the data, learn the normal patterns, and then detect anomalies, correlate the anomalies into incidents, and send alerts. And the advantage of that for telcos is, first of all, it reduces the need to create manual rules for fault alerts. It reduces the need to start correlating manually all these fault alerts that come from different parts of the network, so root cause investigation can happen. It does it all autonomously, automatically, using machine learning algorithms, which basically does two things: both reduce the time to detect issues, reduce the time to remediate issues, and reduce the cost of actually maintaining the monitoring systems that are required in every telco.
I know you have a focus on autonomous remediation. Perhaps we can elaborate on that. I mean, what is it exactly and how can it be used in telco networks?
Great. So that's a great question. And basically the next step of Anodot, of our product, and we already started on that, is to close the loop. Basically, a monitoring system detects stuff and helps you understand what happened much quicker. But wouldn't it be great if this monitoring system can also remediate some of the problems that it detects? And that is indeed possible. And we talk a lot about it in the telco sense, in terms of zero-touch networks, and bring it down to earth or down a notch from the big word of zero-touch network. Let's talk about autonomous remediation. So basically letting a system that monitors also decide what are the remediation actions to fix certain incidents that it detected. And the reason it can happen today is because if you have a system that can detect the issues, it can also observe whether a remediation action taken can fix the issue. Did it fix the issue or not? If it didn't fix the issue, it can learn that, well, maybe there's a better action to take to remediate that same incident. So that's the autonomous remediation part, which we're working on as of today, constantly. That's the next generation of monitoring systems, are monitoring systems that can actually fix problems and not just alert on problems.
Yes, and clearly those benefits to telcos are great, particularly if you could fix problems before they actually impact the customer.
Exactly.
But I'm wondering, there must be a lot of challenges in making this actually work. I mean, what are the main hurdles to overcome?
Yeah, so obviously this is not an easy thing to do. So let's talk about the technical hurdles first, and then we can talk about the more human hurdles or the organizational hurdles. So in terms of technical issues, first, you have to create automations that can fix problems, that could do remediation. Let's take a very simple one. Let's say you want to do, an automation can restart a cell tower because something is wrong with it, just doing a restart. So you need to create these automations. So you need to create the remediation actions. And that's something that companies are working on. Automations in IT, it's being done a lot. And now in telcos, it's being done more and more, creating those automation workflows that, these are remediation actions you can take. So that's the first step. It's very technical and it's very solvable as well. However, now you have to map these remediation actions, these automations, to the incidents that are appropriate for them to be applied on. This is the hard part. And historically, if you look at other systems in other domains, in IT and even in other domains, the way people solved it was with rule-based systems, basically creating a rule. If this happens and this happens, then apply this workflow to remediate the problem. Let's take this cell restart problem, cell restart automation workflow. If I see that on a cell tower or on a site, I have all the calls drops or a lot of calls drops, throughput drops, and success rate of calls also drops, then maybe the right action is to do a restart of that cell. And I can create the rule-based system that will decide. However, the problem with those rule-based systems is that there are so many ways things can go wrong, and it's not clear which remediation action. Well, for very simple things, you can create these rules, but as things get more and more complex, which they do in any telco network, you're going to start having a very complex rule-based system that's going to basically explode in the number of rules. And as we've seen in the history of rule-based systems, once they start getting too big, they become very stale, because it's very hard to add any new rule to them, because you don't know what other rules it will break or contradict. It's very hard to test them. And it's very hard to change any existing rules. So people end up with a fixed set of rules and they are afraid to touch it. So that's a big challenge for trying to apply the old way of doing, I would call remediation or rule-based, system-based actions to this domain of telcos. And really, the way to go is probably with a new approach. And as I probably alluded to earlier, the approach that we strongly believe in, and I think that we hear it also in the market and from analysts, is that using machine learning can actually do away with the need for rule-based system. So that's the challenge on the technical side. There are challenges on the human side, I would say the organizational side, of trusting a system that will take automatic remediation, building up the trust in any kind of system that does automatic actions is always hard, especially when these automations can cause havoc on the network, right? I mean, if the wrong remediation action is taken, it could cause problems in the network. So building up that trust is a big challenge, but that can be solved over time. And also you solve it by stages. You first choose a small set of remediation actions to allow the system to take, or you let the system recommend actions instead of taking them automatically, and then have a human review these recommendations and take the action manually. And over time, you build the trust, and you can get more and more autonomy to the system that does the monitoring and remediation.
Yeah, and you mentioned the complexity of a rules-based system, and that could sort of spiral out of control, that complexity. And you touched on machine learning. Perhaps you can just elaborate a little bit more on the attractions of using machine learning in business monitoring of this sort.
Right. So even what the Anodot approach, even for the monitoring part, for the detection and the root cause analysis, we took the approach of machine learning and basically anomaly detection and clustering algorithms for the root cause analysis. The reason we took the machine learning approach rather than a more deterministic rule-based approach, which has been the approach of monitoring systems, I'll say forever, is that machine learning, its advantage is you don't have to, you can adapt, you let it adapt, you let it learn from the data, and you don't make determinations based on what you know so far in the history, but could change over time. And it can also, if you're talking about anomaly detection, it can detect things that you never thought about because it learns the normal patterns. It lets the data talk and not the human biases talk when creating those rule-based systems. Now, for remediation, it's the same thing. Because networks are very complex, and these remediations, you're going to have a large set of potential remediations, and you have a large set of potential things that can go wrong. It's very hard to manually map them. If we were a power plant, or let's say a nuclear power plant, then yeah, you can create these rules. You can work 2 years on creating these rules, 5 years on creating these rules. They're going to last for the lifetime of that power plant. if you're talking about a telco network, if you spend 2 years on creating the mapping between the remediation automations and the potential incidents, by the time you're done, your network has already changed and you have new technologies, you've changed architectures, you've added new things. So it's never going to bring any value. It's going to be very hard to make it bring value. With machine learning, the advantage is it can look at data. You can let the system learn from some seed remediation actions and incident mapping, start by doing a little bit of manual, and then let it start recommending. Once it starts recommending actions, if it can track what actions were actually taken, it can observe, did these actions make the right impact? Did it make the incidents go away? Did it really remediate the problem? If it did, you can strengthen that, what you learned about this action and its mapping to different incidents. If it didn't, you can learn that as well. So basically, you're letting a system constantly learn. You can add more remediation actions as you want, as you wish. There will always be incidents in the network. That's never going to go away. That's life. So you're always going to have more and more data to let the system learn from, which means even if there are changes in technologies, changes in architectures, all you have to do is let the system continuously learn. So of course, if you completely change your architecture, it's going to have some ramp time to learn, but it's always learning. And that's the good thing about it. You never have to manually all the time configure it and try to change your rules and worry about that. You let the system learn because it's a closed loop system that can observe what happens when an action it recommended or applied automatically, what it did. And that's the advantage of the machine learning. And of course, with advances in algorithms in machine learning, you can do it more and more and more accurately with less and less data sometimes in certain algorithms. And it really is a scalable solution that can last potentially forever, no matter how your architecture changes, no matter how technology changes over time, it's going to be the same system and it's going to continuously learn. And that's the advantage.
Well, thanks very much, Ira, for your insights. And I think that idea of scalability, as you say, is crucial. And that can't be done with the old way of doing things, as you said. So thank you very much, Ira. It's been great talking to you. Thank you.
Thank you very much.